This is example 1 of section 1.1. I'm given three-dimensional vectors, and I want to know if S can be written as a linear combination of P and Q. In terms of vectors, that would mean there are coefficients A and B, such that A times the vector P plus B times the vector Q is equal to the vector S. Writing that out in components, here's P, 1, 2, 3. Q is 2, 5, 2. And S is 8, 18, 10. Now, the thing to recognize is that this is actually three scalar equations and three unknowns. And so it's about solutions of a system of linear equations. So the first equation, looking at the first components, is A plus 2B equals 8. Second, 2A plus 5B equals 18. And 3A plus 2B equals 10. So there's my three equations, and I'll number them to keep track of them. 1, 2, and 3. And now I ask, is there an A and a B that will satisfy all three of those equations? Well, generally, with two unknowns, we'd get a solution with just two of the equations, if we were lucky. And so let's just take two of them and see if we can get a solution. I'm going to take the first and the third. I'm going to take 1 and 3 because, well, I'll have two equations and two unknowns, and what we do is eliminate one of the unknowns and be left with an equation for the other one. And I've got these two 2's here, so those two coefficients are the same. So if I subtract the equations, one from another, the b's will come out. I'm going to subtract 1 from 3 because that will give me 3 minus 1 here, which is positive. So I'm going to take 3 minus 1. And that will be 3a minus a, which is 2a. And then, of course, 0b equals, so 10 minus 8, which is 2. And so 2a equals 2. So that means a equals 1. Okay, so a is 1. And now I'll get b by putting it into either of the equations. Let's put it into the first equation. So put a equals 1 into equation 1. I get 1 plus 2b equals 8. Now I'm solving for the remaining variable, still using those two equations. That gives me 2b equals 7, b equals 7/2. So there's my solution. It's a unique solution to those two equations. It satisfies both those equations. Now the trick is, remember, a solution has to satisfy all three equations. We put that back into 2 and ask if there's a solution. Okay, let's do that. 2 is then 2a, 2 times 1, plus 5b, 5 times 7/2. That has to equal 18. So let's see what it does equal. It's 2 plus 35/2, and that's 4/2 plus 35/2, which is 39/2. Is that equal to 18? Certainly not. No. 36/2 would be 18. No. So no solution to all three equations. So S cannot be written as a linear combination. P and Q. And we're done.